We've looked at multiplying exponents with bases that are the same and different. Let's look at dividing exponents with the same base. So here we have a couple of examples. Let's take a look at our dividing powers rule. You'll notice here it says that if we have a to the m over a to the n, then the result is a to the m minus n. So let's see what that looks like with this first problem. So we have y to the fifth over y to the fourth. Now what that is, if you want to look at it like this, it is really y times y times y times y times y. So we have 5 y's on the top, whoops, and we have 4 y's on the bottom. So 4 y's down here, y times y. Now if you want to cancel them out, that's really, anytime you have anything divided by itself, like y divided by y, that's going to be 1, because 4 divided by 4 is 1. Anything divided by itself is 1. So what we can do is we can actually look at it like this, and we can see that those y's give us 1, and y divided by y gives us 1, and y divided by y gives us 1, and y divided by y gives us 1, leaving us with just a single y. And that's going to be our answer down here. But in order to follow these rules, we would say that that is y to the 5 to the 5th power minus 4. Y to the 5th minus 4 gives me just y to the 1st, or y. Over here, again, you can think of it like we did over here. We've got 3 d's on the top and 9 on the bottom. Or you can think of it like this, d to the 3rd minus 9th. So d to the 3 minus 9 power. That's going to leave me with d to the negative 6. And I can't leave that negative exponent there. So what I'm going to do is I'm going to take that and drop it to the bottom, just like that. So it's 1 over d to the 6th. A couple more here. We've got k to the 6th over k, so we're going to subtract 1 from that k to the 6th. That's going to give us k to the 5th. We have j to the 2nd over j to the 5th, and 2 minus 5 is negative 3. J to the negative 3, and again, I can't have that, so I'm going to make that k to the 5th. I'm going to drop that j to the bottom. It's going to leave me with k to the 5th over j to the 3rd. A to the negative 3rd right here, to the negative 3rd minus 5. So that's going to give me a to the negative 8th. A to the negative 8th, negative 3 minus 5. And then b to the 7 minus 2, and 7 minus 2 is 5. So that's b to the 5th. Again, I've got to get rid of my exponent, so I wind up with b to the 5th over a to the 8th. Now let's move me over here like this. Woo! And we'll do this problem right here. We have got x to the 4th over x to the 4th. That's going to cancel each other out, right? So x to the 4th divided by x to the 4th is just 1. We'll get rid of those. Y to the negative 1 minus negative 5. I'm going to add the opposite. So that's going to leave me with y to the negative 1 plus 5, which leaves me with y to the 4th. And then z to the 8th minus z. That's just going to leave me with z to the 7th. Make a little z there. So I'm left with y to the 4th, z to the 7th as my answer. Now let's use what we just learned to solve a problem that's a word problem, and it deals with scientific notation. And scientific notation is really just numbers multiplied that have same bases with a power. So population density describes the number of people per unit area. So that's important, the number of people per unit area. So it's people over the unit area. All right, and we have two values here, 4.81 times 10 to the 5th. That is the area. So we can tell that's going to go on the bottom since it's per unit area. 4.81 times 10 to the 5th. And then the number of people, which is 1.21, times 10 to the 7th. Now we're going to have to use some long division here. We're going to say that it's 0.25. So let's write that down there. So it's going to be 0.252 times 10 to the what? Well, we've got these exponents here, so we know we're going to subtract these. So 7 times 10 to the 7 minus 5 power. That's going to be 0.252 times 10 to the second. And since that's a fairly small number, let's go ahead and deal with that. We know that times 10 to the second, we'll convert it to standard notation. We know that's going to require us to move that decimal point to the right 2 places. So we know we're going to wind up with 25.2 people for every square mile. All right, and we're done.